Okay, we're going to talk about creating and solving equations, and this right here is incredibly important, and it is something you will never stop doing. You are going to have to take words, turn them into numbers and symbols, and solve them. And we're just going to do a few practices. I'm going to do a lot more in class. Try to get some resources so we can just drill through this and train our brains. You can use what you know about writing algebraic expressions, right, to write an equation that represents a world situation. An equation, I'm just going to put a little equal sign in here. That's the difference. There's an equal sign. Suppose Corey and his friend Walter go to the movie. Each of their tickets costs the same amount, and they share a frozen yogurt that costs $5.50. Total amount they spend is, that's an important word. The word is tells you that the relationship describes an equation. Is actually means equals. Alright. The word total tells you that an operation involved is, and I'm just going to put the sign here, addition. Total means you're adding something. We could have said sum, right? We could have said added, but total and sum are things that you're going to see. Alright. And let's see. What numerical information do you have? Well, numerical means numbers. I mean, we know each ticket, I think. Oh no, not that. We know the yogurt costs $5.50, and we know the total is $19.90. What is the unknown quantity? Well, let's find out. They share frozen yogurt. And the price of the tickets. Price of 2 tickets. That is our unknown. We know that they have 2 tickets. Maybe I should put that up here. They have 2 tickets. Alright. Choose the name of the variable. In this case, C will be cost. Right? That's the cost. So we'll put that over here. Cost of the tickets. The verbal description is twice the cost of ticket, right? Because they bought 2 of them, plus the cost of yogurt. Should have put an R up here, huh? Equals total. All right. Write an equation. To write an equation, write a numerical or verbal, either way, expression for each quantity, and insert the equation sign in the appropriate place. What an equation is, I'm actually going to leave this blank. So here we go. Here's going to be, we're going to write a verbal model for the situation described. Alright? How can you use a verbal model? So what I do is I like to put boxes. Alright? I'm going to say 2 times price of ticket. Maybe I should have made that box a little bigger. Plus, make this one bigger, price of yogurt equals total cost. I'm going to keep going. I'm going to keep that around, but I'm going to keep going. Alright. Could you write a different equation explaining this reasoning? Alright, so I'm going to do this right here. So I'm going to say 2, let's write this as a algebraic expression. 2 times price of ticket, we're going to say 2 times C plus price of yogurt, which I think we have at $5.50, equals $19.50 was our cost. And that's all the information they give us. Alright, I'll also put a 0 here since we're talking about money. And that is 55. So we're looking at another one. Could you write a different equation to describe the situation? Explain your reasoning. I could probably write it a little different. I mean, we don't have to say 2 kinds. We could say ticket plus ticket, right? Instead of writing 2 times the ticket, plus yogurt equals total. But we always have to have the same values in there. All right, we always have to get 2 tickets and 1 yogurt. So we can write them differently. We can put them in different orders, but the same values have to be there. I'm going to say that. Same values present. Now, this is something we just need to practice. So I'm going to drill with this in class a lot before I start you on your homework on these. But it's something that definitely needs to be practiced. All right. We're at 5 minutes, and I'm going to see if I can get a couple more pages done, or at least one more page, because most of this is given to us. And we'll stop after that. So when you create an equation to model real-world problems, your equation may involve the distributive property. All right. When you solve a real-world problem, you should always check that your answer makes sense. All right, so we have the distributive property down here, and we're going to look at it, right? Aaron and Alice are bowling. Aaron's score is twice the difference of Aaron's score, and Alice's score is twice the difference of Aaron's score in 5. All right? The sum of their scores is 320. Now, this is kind of a difficult one, but you get used to it, right? If you write things out. Write a verbal description, all right? The sum, and here it is. I'd have done it with boxes. I would say this. I would go Aaron's score plus Alice's score equals total. All right. And then when you choose a variable, right? All right. It'll tell you Alice's score is twice the difference of Aaron's score in 5. And there's a tricky part right there. So usually, since you're comparing Alice to Aaron, you make Aaron's A. Now watch me write this. I'm going to read it as I write it. Alice's score is twice the difference. That means I'm going to double whatever I get from a subtraction problem. Twice the subtraction problem of Aaron's score and 5. And then I think they give us the total is 320. Alright, so I just said that as I went along. I might have done it a little bit different, but we're going to have the same equation. So look, let A represent Aaron's score, and 2A minus 5, twice A difference. This parentheses represents A difference. If I had twice the sum, that would be a plus. If I had twice the product, I'd be multiplying in here. If I had twice the quotient, I'd be dividing in here. So there's our equation. Now, I hope you remember distributive property. It's a little bit of kind of a rainbow is what it used to be called. So whatever's outside gets multiplied by everything inside. 2 times A, 2A. 2 times negative 5, negative 10. And all that's equal to 320. These two are like terms, which gives you a 3A. And then you solve with the properties of equality. You undo negative 10 with plus 10. You undo times 3 with divided by 3, and you get Aaron's score is 110. All right. Check to make sure it makes sense. You plug in 110 here, and it sure does. All right. So we're going to do one here together. I don't think it does go a little bit on the other side. So here we go. And then we're going to stop. So I'm at 8 minutes. This could be quite a long one, but it's going to be a few pages. All right. So Marie, Carlos, Amanda collect stamps. Carlos has 5 more stamps. I want Marie to be X right now. We'll see if that's what it is. And Amanda has 3 times the stamps Carlos. So since Carlos is compared to Marie and Amanda's compared to Carlos, I'm going to take what nobody's compared to and make them X. Although together they have 100 stamps. The number of stamps each person has. So here it is. I'm going to do my squares, right? I'm going to say Carlos plus Marie plus Amanda equals total. I'm just going to write it underneath. So watch me do this. You ready? Marie is X. Alright. Now watch me say this. Carlos has 5 more than Marie. So Carlos is X plus 5. Alright. And Amanda has 3 times Carlos. So Amanda is 3 times Carlos, which was x plus 5. And you just kind of, what was the total? We say the total is 100. And you just kind of work your way through like that. You compare and you go up the line and make it make sense. Marie was x, Carlos was 5 more, and Amanda was 3 times, and there's what Carlos was, right? I just bring Carlos in there. So if we got this, let's see. We're going to skip this part because I drew it already, right? And they used s instead of x, right? So that was Marie. Carlos was x plus 5, and Amanda was 3 times x plus 5, which equals 100. They wrote it in a little bit different order, but you can see what we did there, right? So s plus, we'll write it again, x plus 5 plus 3x plus 5 equals 100. And then they used s. I used x. So I'm going to keep using, I'll switch over here. So if I distribute that, that's 3s plus 15 equals 100, right? Combine like terms, there's an s, and a 3s for 5s. 5 and 15 are 20 equals 100. Undo this 20 by subtracting, that gives us 5s equals 80. Divide by 5 and we get 16. So if s is 15, 16, Mariah is s, right? She's the variable. Mariah was the variable, so I plug that in, 16, right? Carlos is, I'll write it up here, 16 plus 5, which makes him 21. Amanda is, well, let's think about it, 3 times 21. She's 3 times Carlos, which gives her 63. Right, and make sure it makes sense. Well, we can just probably plug everything in. 16, 21, 63 equals 100. And sure enough, those add up to 100 and 100. We're golden. Would a fractional answer made sure? Well, when you answer this question, right? When you answer this question, you think about what you're dealing with. We were dealing with stamps. So I'm going to say no. Half a stamp doesn't make sense. So when you get halves on something like this, check to make sure your work is right. All right. What might it mean if we check and read the answer to a real world problem did not make sense? It may mean we made a mistake, which is why we always check our answers at least in our heads. At least in our heads. So we have gone through a huge chunk of this. I'm going to post this and keep going. What I want you to do is, you know what? I'm just going to do this with you. Don't worry about it. We'll walk through together and practice in class. So, next video.